The focus of this section is operators. Operators is a fundamental part in any programming language, and they share a lot of properties between different languages. We will start with focusing on the arithmetic operators. The arithmetic refers to the traditional math operations like addition, subtraction, and so on. So we can now read this program and we can understand it already. So we have here a couple of variables. Then we start to say x plus y. So this is an arithmetic operation. X here is the operator. It is a symbol. And the x and y, we call them operand. Something like x plus 2 times y minus 1, we call it an expression, which eventually bunch of operations like that. It can be as simple as a single integer, but it can be also a bunch of operations like that. So we can trace normally this kind of equations, and there is something here, the parentheses here. The parentheses force an order. If I say it's something like parentheses x plus y over 3 and x and y with 3 and 6, then this would be 9, then 9 over 3 with 3 over 3 would be 1. But if you remove this parenthesis, the one from here and the one from here, it will be now x plus y over 3. So it will be first y over 3. Y is 3, 3 over 3 is 1, 1 over 3 is with third. So it will be like 6 plus third. So you see how the parentheses here force the priority in evaluation. And we will come back later to that in the operator precedence. There is also what we call a binary operator and unary operator. The binary operator needs two operands. For example, it needs two values, like 3 plus 5, 4 times 6, 5 minus 2, and so on. There is also what we call a unary operator. In a language like C++, we have several unary operators, but in Python, it's as simple as only minus or plus, for example. And remember from the math rules, if you said something like minus 7, it is just 7. Minus 7 is just minus 7. So every couple of minus are just cancelled. We can also say plus. And as you observe here, the plus and minus can be used as binary operators and also as unary operators. So here are some tracing examples. Minus 7, minus 7, minus 7. Definitely this is meaningless. I'm just showing you the language capabilities. 7 minus 5, so minus is just a math like a plus, so this is just 7 plus 5. But 7 minus 5, so this couple of minuses will be cancelled. It's now 7 minus 5 with 2. This is just how things in math go. We have also what we call division, and we all know about it, but also Python had an extra thing. It's called floor division. And there are differences in that in Python 2 from Python 3. But now let's focus on Python 3. Let's see the normal division. If you divide something like 14 divided by 2, it's just 7. If you divide it by 3, this will result in a fractional number. If you divide it by something bigger than 14, it will be 0 point something. Now, coming to the floor division, or what we call integer division, it means to discard the fractional part. For example, when we divided 14 by 3, we have this 4 point something. In integer division, we discard this 0.6 something and we just keep the 4. So we have here the answer is 0.35, but here it will be just the 0. So that's all. Now let's see this floor division when it comes with negatives, because it's a bit tricky. If we have 14 divided by 8, this is 1.75. If we have 14 integer division by 8, then we will discard the fractional part, is now 1. If we have minus 14 divided by 8, now this is tricky. The formal rule is we are actually rounding down to a small value. For example, here we have 14 divided by 8 is 1.75. Which one is less, the 1 or the 2? It is the 1. But here, minus 14 divided by 8, which one is the minimum? Is it the minus 1.75 or the minus 2? It is the minus 2. So you can think of it as going down toward a smaller value. So the negative case is a bit tricky, so be careful of that. Remember also the type function. We can say type of 14 divided by 7. This would be float. But the type of 14 integer division by 7 is just integer. The division by 10s is very interesting. We can have here the normal divisions by 10 to get maybe 1, 2, 3, 4.5, 0.45, 0.35. This is totally okay. But what happens when you divide integer divide by tens or power of tens? You notice here it looks like we are just getting rid of the fractional part here. This 0.5, 0.45, 0.345. So looking to these guys here, we are actually removing the last digits. So when we divided by 10, it gives us 1, 2, 3, 4. So we get rid of 5. When we divided by 100, it gives us 1, 2, 3. We get rid of 4, 5. By 1000, we get rid of 3, 4, 5, and so on. So overall, the integer division by 10 is very interesting because it helps us to remove digits from the end of the number. There is also what we call the power operator or the exponential operator, which is just a multiplication of something in itself several times. In math, we write it this way: 5 to the power of 3. Here in Python, we write 5 asterisk asterisk 3, which is just 5 raised to the power 3. So 5 to the power 3 means multiply 5 times itself 3 times. So here are some examples. If you multiply 2, if you computed 2 to the power 4, it will be 16. 2 to the power minus 4 is just 1 over 16. Two interesting cases. 5 to the power 0 is 1, and 0 to the power 5 is 0. These are just all math things. If you don't know them, then anyway the power operator is rarely used. Also, you can compute with floats. Can the float value be here in the lower value or even in the upper value? Again, as we said in the last slide, dividing by powers of 10 remove the last digits. So let's say you have number here and you would like to remove the last 3 digits. Dividing number by 10 to the power k will remove the last 3 digits from here. The modulus operator is mainly about the remainder after you divide some operation. So for example, when you divide 6 mod 4, the answer would be 2. This is the remainder of the modulus operation. We have a separate video to go in details about the modulus operator. But what might be interesting at the moment is to know even numbers are divisible by 2, but odd numbers aren't divisible by 2. So this is mainly, the modulus is all about the divisibility. So if you have something like 2, 4, 6, 8, 10 and so on, and you divide it by 2, you will always get some number 0.0. So 8 divided by 2 is 4.0 and so on. But if you divided all the odd numbers by 2, you get always some number 0.5. So dividing 1 by 2 is 0.5, 3 by 2, 1.5 and so on. So the moral of that is even numbers are divisible by 2. Odd numbers aren't divisible by 2. That's all.